Hey guys, so welcome to lesson 11.5. This is our last lesson of the entire school year. So I know that's so hard to believe, but I'm so proud of you guys. We have made it and great job. You know, before distance learning, you guys were awesome in the classroom and you have all transitioned so beautifully to distance learning. So really, I couldn't be any prouder of you. So let's jump right in here to our last lesson. It's not too long. And so let's get started. Today we are looking at rational equations and solving them. Okay, remember, and I keep going over it, but it's so important for you to know, when you see that word rational, we are just referring to a fraction. Okay, rational is going to be the more developed math word that you use to talk about fractions. All right, especially when they involve variables. So we're basically going to be solving equations that have fractions in them today. Now, we want to identify what exactly is an equation. So, the difference between an expression and an equation is that an equation has an equal sign. Okay? Equation has an equal sign. Very, very important. So here in our second bullet point, we see that we simplify expressions. So when the directions say to simplify, like for this example, we would just divide the numerator and the denominator by 3, and we would end up with 4x over 1. So this is an example of an expression being simplified. Here in bullet point number 3, we solve equations. So notice this equation has my equal sign, and in order to solve, you want to get the variable alone. So I want to get this x alone. I would multiply both sides by 3, right? I would get 12x equals 30. And then I would divide both sides by 12. All right? And so notice my final answer is going to be x equals 2.5. Okay? So simplifying expressions looks like this. Solving equations have an actual traditional answer where you tell me x equals something. Now let's take a look at how we're going to solve these rational expressions because they are going to look a little intimidating. Step 1 is to factor the denominators. Really, the only method that we're going to be using for factoring today is GCF. We're not going to be getting too in-depth with any examples that are too crazy. So really focusing on GCF, breaking everything apart. So for example, if you have 6x, breaking that down into 2 times 3 times x. After we factor the denominators, we identify the least common denominator. So you tell me what that is. But notice here when we are solving, step 3 is what's different. Okay? You do not want all the denominators the same. So we just identify the LCD, but then you multiply the numerators. Remember, the numerators are the top parts of the fraction. So you multiply everything on top on both sides of the equal sign. So if we have 2 over 3x plus 4 over 6x equals 7, you multiply everything in the numerator on both sides of the equal sign. Okay? The whole reason that we do step number 3 is so that we can do step number 4. We want to get rid of all the fractions. Operating with fractions, as you guys have seen this chapter, is very difficult. So what we really are trying to do here is to get rid of these fractions, and then we can solve in step 5 much easier. All right, guys? So we're going to go through 3 examples, and then that's it, and then you guys will have your homework. As always, there are multiple ways of solving these types of equations, but this is a really, really good starting off point for you guys to learn. So here's our first example. We have 3 over 2x minus 1 over 3x equals 5 over 6. And notice our directions tell us to solve. So step 1 is to factor the denominators. So I have 2 times x, 3 times x, and 2 times 3. Remember for step 2, to identify the LCD, I look at my denominators and I take one of every factor. So I'm going to take this 2, and notice since it has a partner over here, I do not need to take the partner. Okay, I can cross out the partner. I take this x over here. Since there's a partner over here, I can cross out this x as well. Okay, remember, we're only taking one of each factor. Then I take this 3 over here. It has a partner, but I don't need the partner. Okay, so the 3 parts that I'm going to use for my LCD are going to be 2 times x times 3. So my final LCD is going to be 6x. All right, so I've identified my least common denominator. Now my third step, multiply all the numerators on both sides by the LCD. So I'm going to just rewrite my equation down here. I would have 3 over 2x minus 1 over 3x equals 5 over x, or 5 over 6, I apologize. I know my LCD is 6x. So to follow step 3, I'm going to multiply all my numerators by 6x. So 3 times 6x, 1 times 6x, 5 times 6x. I do not multiply the denominators. Okay, guys? So you're just identifying the LCD and then multiplying your numerators by the LCD. The whole reason that we do that is because of step 4. You want to cross out and get rid of the fractions. So for example, do you notice here in my first fraction, the x and the x can now cross out. The 6 over 2 can become 3 over 1. Okay? And that 1 in the denominator can be invisible. So really, instead of that whole fraction, I now just have 3 times 3. I'm going to bring down my minus sign. Now for this second fraction, I can cross out the x's. My 6 over 3 can become 2 over 1. The 1 in the denominator can cross out. So for the second fraction, I now really have 1 times 2. I still carry down my equal sign. For my third fraction, notice the 6's cancel out. So now I just am left with 5 times x. And do you see how now we have a very solvable equation? Okay, guys, this is something going back to middle school that you guys have seen before. So let's just simplify from there. 3 times 3 is 9. 1 times 2 is 2. 5x. So 9 minus 2 is 5x. 7 is 5x. To get the x alone, I divide both sides by 5. So my final answer, x equals 7 over 5. X equals 7/5. Okay? So that's it. We have 2 more of these, all right? But hopefully you're kind of getting the hang of it. All right, here's our next example. Again, solving using the common denominator. So, factor the denominators. There's nothing to factor with the 5, nothing to factor with the 2. I actually have a slight issue over here with the 3. There is no denominator. So how do I make the 3 into a fraction? You can put any whole number over 1. Okay? And really any expression to make into a fraction you can put over 1. So we've done step 1. Now let's do step 2, identifying the LCD. So remember for the LCD, I take one of each unique factor from the denominator. So I'm going to take the 5. There's no partner to cross out. I'm going to take the 2. There's no partner to cross out. And I'm going to take the 1. Again, there's no partner to cross out. So for my LCD, I have 5 times 2 times 1. So that means my LCD is going to be 10. Okay? Let me rewrite my equation. 2x minus 3 over 5 plus 4x over 2 equals 3 over 1. Because step 3 tells me to multiply all the numerators on both sides by the LCD. So if the LCD is 10, I'm going to do 2x minus 3 times 10, 4x times 10, and 3 times 10. And notice I'm putting these parentheses around my expressions just so that I can have that separation. Now let's go to step 4. Get rid of the fractions by crossing out. Remember, the whole point is to get rid of these fractions. Operating with fractions is not very fun. So let's go ahead and cross out. In my first fraction, 10 over 5 can become 2 over 1. So I now have times 2 over 1. And remember, the 1 can be crossed out because it can be invisible. So this fraction, I now really have 2x minus 3 times 2. Okay? I'm going to carry down my plus symbol. For my second fraction, the 10 over 2 can become times 5 over 1. Remember, the 1 in the denominator can cross out. So for this fraction, I really have 4x times 5. I put my equal sign, and then for my last fraction, the 10 over 1, I can just cross out that invisible 1, so I really have 3 times 10. Okay, guys? Hopefully you see how we've gotten to this step. Now let's go ahead and solve. For this expression, I need to distribute that 2 to the parentheses. So I get 4x minus 6, then 4x times 5 gives me plus 20x, and then 3 times 10 gives me 30. Okay, let's add the 6 to both sides. So when I add that 6 to both sides, I end up with 4x plus 20x equals 36. From here, I'm going to combine my like terms. So I get 24x equals 36. And then my last step is just to divide both sides by 24 to get that x alone. So my final answer for x would be x equals 1.5. And again, we are solving, so that means you're getting an equal sign for your answer. Okay? One more example. All right, guys? So here we go. Last one. Again, notice my directions say to solve, so that means my answer is going to be x equals. Step 1 is to factor the denominators. So notice there's really nothing to factor, but keep in mind I'm going to put parentheses here so that we know the x plus 3 is glued together. And then to make 1 into a fraction, I'm just going to put it over 1. All right? So now let's identify the LCD. So notice you need to take one factor from each denominator. This entire thing is a factor. X plus 3 is a whole factor. So I'm going to take x plus 3 times, my next factor is 5, so times 5, and then times 1. Notice there was no partners along the way to cross out. So my final LCD is going to be 5 times x plus 3. Notice you do not need to distribute, okay? We don't need to distribute when we're dealing with common denominators. So let me rewrite my problem. X over x plus 3 plus 3 over 5 equals 1 over 1. Because now we're going to go to step 3. Multiply all the numerators on both sides by the LCD. So here's my LCD, and I'm going to multiply all the tops by that. So times 5 times x plus 3 times 5 times x plus 3 times 5 times x plus 3. Now remember, what is the whole point of doing that? It is to do step 4, which is getting rid of the fractions. Remember, we don't like fractions. Fractions are difficult to work with. So in this first fraction, what can I cross out? I can cross out the x plus 3 on top, the x plus 3 on the bottom, and now I just have x times 5. So that whole fraction just becomes x plus x times 5. Then I carry down my addition sign. For my second fraction, what can I cross out? That 5 and that 5. So now I'm just left with 3 times x plus 3. I carry down my equal sign. And for my third fraction, the invisible 1 in the denominator can cross out. The invisible 1 in the numerator can cross out. So I'm just left with 5x plus 3. Woohoo! So we've made it here to this step. Now let's start simplifying and solving. X times 5 gives me 5x. Here for my second expression, I do have to distribute that 3. So I get 3x plus 9. And then for my last expression, I also have to distribute that 5. So I get 5x plus 15. From here, let's combine our like terms. 5x plus 3x gives me 8x plus 9 equals 5x plus 15. Let's keep combining our like terms. Let's subtract 9 to both sides. And so now I end up with 8x equals 5x plus 6. Let's move the 5x to the other side by subtracting it. So I subtract 5x to both sides, and I now have 3x equals 6. So my final step to get the x alone is to just divide both sides by 3. And my final answer, guys, is going to be x equals 2. Woohoo! So again, I know this is a little tricky, but I hope you are all able to see that this is very doable. You guys are capable of doing this, okay? So here's the last homework for the year, all right, guys? Because after this, we're just going to have the test review and then getting ready for the test, all right, and the final exam. So homework 11.5, again, this is in Google Classroom, so you can get the PDF from there and also upload your homework. Notice it's only 4 problems, okay? 2, 3, 6, and 7, only 4 problems. Look at your denominators. They're not super complicated, okay, guys? So you're just going to be looking for common denominators. Then remember, you multiply all the tops by whatever those common denominators might be. So for example, in question number 3, the least common denominator, I'll already give you guys a hint, it's going to be 10x. So you multiply all the tops by 10x, then you start crossing out. Like the 10s can cross out here, the x's can cross out here, the 10 over 5 can just become times 2. All right, the x's cross out, the 10 over 2 can become times 5. All right, so just giving you guys a little something to work with here. Okay, guys, so again, just so proud of you all. Thank you for all the hard work you've put in with distance learning. If you have any questions on this lesson, please put it there in the comments in Google Classroom, and I'll be more than happy to help you guys, okay? Love you all, and I will see you guys next time.